Hey everyone, I'm TJBChris. Welcome back to the channel and to part 2 of my series Exploring 513, a look at the Memorex VIS. I hope you enjoyed part 1. I realize it was a bit heavy in the book report department, but if you're going to build upon something and really get into the detail, you've got to get the foundation in place, and that's what we started to do last time. Tonight we're going to have a little bit more foundation, but I promise you we're going to get into some actual computer stuff tonight. We're going to take a look at a VIS disk, and we're going to dive into licensing. And using what we know about licensing, we're actually going to establish ourselves as a vendor of a VIS application, and then I'm going to register a specific application, create a license file for the VIS, and we're going to make a disk, and we're going to actually try it on the VIS. So it's going to be a whole lot of fun tonight. We're going to start to get into a little bit of how the VIS works. And then finally, we're going to take a look at the CD player application that is built into the VIS, because you may not like it as a game player, you may not even like it as an edutainment device, but if nothing else, it makes a so-so $700 CD player in 1992. Okay, jokes aside, it does actually have a CD player in it and lets you map tracks and save information about the discs on the Save It card. So that's kind of fun. Anyway, let's get into exploring 513. And what is 513? I got that question a couple of times. So looking at the different ways you can refer to a Tandy product, there were really 4 main attributes we're looking at. 2 kind of internal and 2 external. The 2 external ones are, of course, the product name, Memorex MD2500 Video Information System, a catalog number, 16-376, and then you've got its project number, 513, and its project name, Gryphon, spelled G-R-Y-P-H-O-N. And let's take a look at a couple of other examples of project names and numbers, just for your enjoyment. The Tandy 1000, catalog number 25-1000. This predates the additions with a DMA and some fixes that was 1000-A. I don't know the project name for this one. I know I did at one point, but for some reason I just couldn't dig it up. But it had a project number of 557. And then, of course, we've got the Tandy Sensation, the original Sensation. That's 25-1650. I was right last time. And that had a project name of Lone Star and a project ID number of 1033. And finally, I'm not sure if the same project number and naming scheme was used back when this particular example came out, but the TRS-80 Model 4, catalog number 26-1067, 1068, or 1069, and later 26-1070 with the Network 3 student stations. Anyway, I don't know its project number, but I have seen it referred to as Project R. So as we start our dive into the VIS, let's take a look at a block diagram of the VIS. And with this up on your screen, we have a pretty good idea of what the VIS was to look like, at least logically from a high level. Taking a look at the right side of the diagram, you can see we've got our various inputs and outputs. We've got our stereo audio jacks, headphone and microphone, the memory card interface, the infrared receiver for the hand controller, a PS2 style port for mouse keyboard or wired hand controller, and then you've got your RF modulator for your television and the antenna in, so just like a Nintendo Entertainment System, you could have the thing take over the signal or not, whether it was on or off, your S-video port, and your composite video port. Note above that the production date that looks like it's 10/8/92 when this was released for production. Now, taking a look at the inputs and outputs, we're going to flip all the way to the left side of the diagram, and we're going to take a look at the system from the bottom up. So, of course, we've got ourselves a 512K by 16 BIOS ROM, so a 1 meg ROM. We've got a battery for storing configuration information and some SRAM. And then we've got a 80286-12, and it says 12.5 here. I don't know if that actually ended up to be true or not. Processor. Now, this says Yamaha OPL3. The sound system is AdLib compatible. I don't know how that relates to the AdLib. I'm not that versed in the AdLib. I believe it's OPL3, but I could very well be wrong. So it may very well be it's just a question of port location and how it's implemented. Moving on to the right, we've got the modem interface board that I mentioned in the last video that never actually made its way into the VIS, but was the same one that was used in the Sensation. Then we've got a system control ASIC. These were fairly common in Tandy and other computers back then, essentially your system on a chip. And we saw one of these actually when we were looking at my Tandy 2500 SX25. It had a Headland chip on the board. I don't know if this is a Headland chip or not. Now I wish I'd looked. We've got some controller ASICs and the DAC. We've got the audio mixer, which the interface to which is rather complex. Moving on, we've got the video DAC, Video NTSC PAL Video Control, which has the codename Van Gogh. We were talking about code names and project numbers before. This is the same DAC that was used in the Sensation. Van Gogh, clever name. Then we've got ourselves the palette DAC, the NTSC encoder, and the various modulation bits. Moving down, we've got the expansion bus, and it says video upgrade bus slot. Now, I believe there's a second slot in there. I have no information on what that was or how it was to be used, and none of the documentation I've seen thus far gives me any clues. Now, as far as I know, given how quickly this thing got shoved off the market, that never came to be. We've got the CD-ROM drive, the headphone amp, and an audio adder, a preamp with ADC for the microphone, the CD-ROM drive, and then the aforementioned hand interface control, and the channel 3-4 selector for the modulator moving from left to right. And we have here the specifications for the Project 1033 and 513 2400 bits per second data modem with send-fax specification. So send only. And if you're looking at 1033 and 513 thinking, ooh, TJBChris, a couple minutes ago we saw those numbers, you'd be right. 1033, as we look at the first paragraph, is Project Lone Star, and 513 is Griffin. That's the Tandy Sensation, the first one, 25-1650, and the VIS 16-376, respectively. And of course, this document goes on to outline all the capabilities of the fax modem, including its AT command set, DTMF, and pulse support. And it has, various on-hook, off-hook circuitry, supports Tandy voice applications. This is called Teleminder. And of course, it can operate at 2400, 1200, and 300 bits per second, compatible with Bell 212A and 103 standards. And it can transmit in fax mode up to 4800 bits per second with fallback to 2400 bits, compatible with V27 TER recommendation. That's a document you've never seen before, just like the block diagram. Where did I get these documents? Well, those documents were donated to the channel for presentation in this series by Tandy Showcase. So thank you, Tandy Showcase, again for that. There's going to be a little more where that came from, but as I mentioned, he has a whole cache of stuff that he's received over the years and collected, been curating from Frank Durda4, Paul Schreiber, and others. So thanks again, Tandy Showcase, for sharing that with me and allowing me to put it onto the channel here. Now to talk about the software environment. As you've probably already guessed, and I've alluded to a number of times now, this environment's fairly standard. And while I did mention a very popular hardware and software environment, I'm pretty sure you all know, because other YouTubers have said it, as have other places on the internet, that this is a platform based on, but not exactly like, your standard MS-DOS and Windows 3.1 platform. However, it is not MS-DOS, exactly, and it's not Windows 3.1, exactly. How can that be? In fact, it's not even an IBM PC BIOS, exactly. It is-ish, but not. Well, we'll talk about the BIOS pieces in another video, but let's take a look at the MS-DOS and Windows side, shall we? So the software that powered the VIS and was intended to power other VIS-like players, multimedia players on Microsoft's mind, was called Modular Windows. The combination of the core DOS-like operating system and the Windows operating environment were called Modular Windows. Let's take a look at the Windows side first. From a Windows standpoint, this is based on the Windows 3.1 operating system and with extensions to support TV-based multimedia players. And there are really some big changes from Windows 3.1, and they may not sound so big until you really get thinking about them. And they are reduced support for the Windows 3.1 API. This is huge. Reduced support for Windows 3.1 extension libraries, but it comes with new user interface controls and new support for hand control input devices. Did I get that right from memory? Yes, I did. So in taking a look at things in Windows 3.1 that are not supported on VIS and what were supposed to be companion players from a modular Windows perspective, things like file write operations to disks were not supported because TV-based players don't support file system-based writes. They don't have a writable file system that you can write to. Things like the menu bar are not supported in Windows. On the other hand, we gained support for very TV-specific things. For example, this hand control. And others like it. Allegedly, they never happened because the VIS blew up so bad. But it did support the hand control and kind of treated it like a mouse in a lot of ways, as you saw in my demonstrations from the last video, where it was clear some of those applications were Windows applications, right? You could see it. Hourglass, arrow, common controls, things like that. Now, interestingly, title bars are supported in some situations, which actually was not a thing I knew. And underpinning all this modified Windows 3.1 goodness is a very heavily modified copy of MS-DOS that supports a subset of standard DOS int21 calls. And let's take a look at that really quick. So for example, we have a bunch of calls here that are supported without change. Now one thing I'll note here is that They don't tell you which ones are explicitly not supported in the documentation. There's tooling for that. We'll cover that in a subsequent video. But they just tell you which ones are supported without change, and flipping to the next page, they tell you which ones are kind of supported. And as they mention here, there's no writable file system, and a lot of file I/O calls have to be redirected elsewhere. But that's just the nature of developing on this platform. There are going to be some things that you're used to in MS-DOS that are not there, and there are going to be some things that you're used to that will be there but different, or may return differently, or when called, do nothing. So the underlying environment is not a just take your DOS or Windows application and run it. You need to make quite a few changes to do that. And that, of course, doesn't cover the underlying hardware differences and differences from a BIOS and video perspective that we're going to cover in a subsequent video. What you need to know for this one is you're looking at a DOS and Windows-like environment called Modular Windows, which had a code name of Haiku, and you'll see that referenced in other videos as well. So looking at the fact that we have a DOS-ish and Windows-ish platform, subsets, and a PC-ish platform with subsets and enhancements that we haven't taken a deep dive into yet, what's to stop some schmo or company from just taking their DOS application and trying to run it on the VIS unmodified? How do I keep people out? How is it that I can make sure that licensees go through me as the developer of this hardware, you know, Tandy? I'm not Tandy, but I'm pretending to be Tandy for the sake of this video. How can I do that? Remembering again that we're not in an internet-connected age like today, where we take it for granted that we can create and revoke keys and issue software updates, certificates, and other things that were not available to developers at the time. Well, what you do is you create yourself a licensing model and a licensing authentication scheme in the player itself. And before we take a look at that licensing and authentication scheme, we need to take a look at a VIS application disk so that we can see what the disk looks like and see if we can identify the licensed assets. So I wanted you all to take a look at my development system here, and this is the system on which I've been testing all of the various VIS experiments that led to this video series, and some other great things you're going to find out over the next month or two. This is my Tandy 4833LX/T Franken Tandy, you know, the 4833 that's really a 425SX mid-tower, sawzalled in to the case for a 4833. I've installed on this a number of development tools, and those development tools span the realms of DOS and Windows, and in doing a lot of experimentation, span the Microsoft and Borland divide, because there's a lot of software out there written in both. Commercially, we tend to focus on Microsoft. Your more independent shareware developer houses, where you had, you know, independent developers and small groups writing things, tend to be more Borland. So I availed myself to both environments from a C and assembler perspective. We also have a copy of Windows 3.1 on here. And if I start Windows here, just so you can kind of see what I've got, and this is running a real hard drive. You may hear it. I also have some additional development tools on here. We've got Microsoft Visual C++, Borland C++ 3.1, and Microsoft C++ 7.0, as well as the program group for the Microsoft Macro Assembler, which quite frankly is just the DOS utilities. Same with C++ 7.0. It's the DOS ones, but it'll create a program group for you. And of course, like I said, Microsoft Visual C++ 7.0. So this is my development environment. And I've got this nice little menu system here that keeps track of your environment and everything else, kind of a combination of environment variables and batch files that allows me to switch development environments with ease. So with all that in mind, let's actually take a look at a VIS disk. And the disk we're going to look at first is the sampler disk. And this is the disk we looked at last time for our example. I hope that was actually visible on the camera there. That is the title sampler that comes with the VIS. And we're going to put this thing into my 4833, and we're going to take a look at the contents of the disk. All right, and I believe this is a DVD ROM drive that's a little newer than the machine itself here, but it should work. Okay, here we go. So let's do this. We're actually going to use Windows for this, just so I can get an easier, more graphical view. Let's navigate our way over to the File Manager, Windows 3.1. Click on Drive D. Let's see what we've got here. Well, we have a few directories over here on the left. Taking a look at the root directory here, we've got some files that don't necessarily make a whole lot of sense yet. We've got a lot of WAV files, and we've got an executable to play some sort of multimedia file here. Looks like these FUV files. We've got menuexe.com, vismenu.exe, and then we've got a couple of subdirectories here. We've got a directory for Space Nuts, which has a bunch of directories, the Space Nuts executable, and a MIDI file, a few MIDI files. I have no sound devices installed on here, so we don't get to play those. But I can open one of these bitmaps, and you can see it's a standard bitmap here. It's one of the explosions you saw from last time. And we'll take a look at, there's credits.bmp, and do we have a title screen on here someplace or something like that? We don't necessarily. What is this? Oh, good SHT. I thought shop, but that's not the first thing I thought. We have a WAV file here, laser. So we got a bunch of various files and things, various assets for Space Nuts. Now, fun fact, friends, Space Nuts will run on your PC. You can run it. Keyboard controls work. We've got Rick Rib, which is the demo for the Rick Ribbit game that we saw last time. This is just the demo executable. And then we've got the AVIs directory, which is used by the Windows application that we saw to run those various AVI files to demo the application. So let's take another look at the root directory here. And what to us stands out? We've got DAT files for AVI Movie. We've got some more WAV files. These FUV files, which I believe are the multimedia files for the animation we saw with the demo, with that weird little owl with no name with the Dorcosaurus. And we have an interesting file here, CONTROL.TAT. This is an interesting file, so let's take a look at this. Let's see if we can type this file from MS-DOS. Okay, here we go. So let's do this. Type control, don't type on camera, .tat. Okay. So all we get out of this is copyright C1992, Tandy Corporation, VIS preview disk. Okay. Looking at this, it's 501 bytes. All right, let's see if we can take a better look at this file, shall we? On the root of the C drive on this machine, I have edit.com, you know, the one from Windows 95 that allows you to open binaries files. So open BN, and we're going to open up control.tat. So automatically we see that there's more than the type command showed us. There is in fact a stop character here to stop type from displaying the file any further. Then in here we have a bunch of control characters that do a combination of telling the VIS what to do, but also making sure that you can't just edit the file. This file is checksummed, and that's actually part of the licensing scheme that we'll see later. And you'll see here this attention. This is an unauthorized video information system title. End of statement. And then we see some, what looks like an executable, a:/13to61.com, menu.exe with a parameter, vismenu.tat. And then we see the make tat version is 1.12, 31 August 92, followed by the end of the file. So in this case, the control.tat file actually tells the VIS not only is it a licensed title, but it tells the system what to do once the thing boots. So in this case, it runs two different programs. The way the VIS runs things is sequentially, and if it gets to the end of the last one, by the way, it just reboots. So it'll run this 13to61.com, which I'm not sure what that is, and then it will run menuexe.com with a control file vismenu.tat, which is another control file here, but with additional support to display the menus, specify the backgrounds and button mappings, things like that. And we talked a little bit about the VIS menu functionality. This is technically built into the thing. You can run VIS menu. Now, menuexe.com is on the disk here in this case, but the VIS player does have support for menus in control.tat. So looking back here, we have, I realized the screen was kind of flippy there, the preview disk here with 1092. That kind of lines up with the fact that the release date was only a month later. And that's pretty much a description of what the control.tat is. There is an additional function in there that allows it to map a button to jump right to the CD player if you want, so you can run the CD player without booting the title on the disk if there may be some audio tracks on the disk that the customer might want to listen to. But with all the binary data here, by the way, FDIV, that is Frank Dirda 4, if you wonder. A lot of folks at Tandy in a lot of different projects had their initials or names in various projects. Another one you can see Ron Light, whose name appears in the Model 4 ROM, and FDIV appears all over the place as well. There are a number of people whose names or initials show up in various Tandy executables, ROMs, etc. throughout the fleet, from TRS-80 Model 1 all the way up through. It's really pretty cool. So this file gives us an idea, a rough idea, of what the player is going to do. And you can't just go modify this file. The player does have a way to checksum it and make sure that the contents of the file line up with the license that was used to create the file. I'm sure with enough license files and enough time you could figure out the algorithm. In fact, this is something the developers were aware of and noted in some of the notes, that over time it was expected that this would probably be broken, but by that time the player would be probably obsolete, or at least the next iteration of the security system would be along. But this is the file that stops you from just running anything on the VIS. And it is this control.tat file and the ability to generate it that has stopped anyone from creating new VIS software since 1993. So let's talk a little bit about licensing on the VIS. Licensing on the VIS is broken into classes, and there were two main classes that determined what your title could do on the VIS. There was Class A and Class C. Class B licenses were not implemented, but they were planned. I don't know what they were meant to do. No one's said in any of the documentation I've read so far. A Class A title had a couple of implications with it. One was that you were a fully blessed and licensed title with Tandy, and that you were allowed to use the VIS logo on your product, on your discs, on your packaging, etc. You were a fully licensed VIS title. A Class A title can be identified by titles which, when you put them into the VIS player, display the Authorized Video Information System title on the VIS when the title starts to boot up. On the other hand, a Class C title will boot up and run, but will not show the Authorized Video Information System title text when the thing starts up. The difference between these titles mainly lies within A, logo use rights and the ability to use VIS trademarks and the like, but also in the ability to use the VIS's menu system. If you have a Class C title, you cannot use the menu system that you saw on the sampler disk when we chose between Crazy Dorkosaurus Owl or the Windows demos or Space Nuts. That's not available to you as a Class C title. But as a Class A title, you've got access to the entirety of the menuing system. I'm a VIS developer, you're saying to yourself as though you're talking to Tandy Corporation. How do I get my awesome title onto the VIS? That's a great question. Now, what I'm about to say is just based on some anecdotal evidence read on Usenet over the years, and also files and documentation, comments and code and things I found in the cache of files I've gotten. So this is my interpretation of this artistic license, but roughly speaking, I think I have a pretty good picture of the high-level process for what you would do and how the process would work. So generally speaking, of course, you'd reach out to Tandy Corporation, agreements would be signed, negotiations would be had, they'd probably ask you, what's your idea? And you would go through the whole, corporate negotiations, fluff, chortle, the whole 9 yards. Anyway, once you're accepted as a developer, you and your development house and your title would be entered into Tandy's registration database, which we'll see later. And from that registration database, a license key would be generated with which you could generate a control.tat file. Now, to generate this file, you'll need some additional utilities, but don't you worry, what you need, Tandy will provide in the form of MakeTat. The name of the utility you saw in the MS-DOS screenshots that we looked at earlier when we were looking at control.tat. Anyway, you'll get yourself a license key for that particular title, and you can go generate that key and run it. In addition, if you are so inclined, you had the option to purchase development boards. These boards would go into a PC-compatible 286 or later system and allow it to, as closely as possible, emulate the hardware of the VIS. Accompanying these boards would be additional software, development tools and the like that would allow you to install the BIOS extensions in said PC to allow those cards to function via the same calls and in the same way that they would in the VIS for the most part. Now, these cards, of which there were 4, are unobtainium. There are only a handful of sets known in existence. No, I don't have any. And I know of a couple of people that do have them, but they're very rare. There will never be more. And quite frankly, if you're going to develop for the VIS, as I'm going to show you in subsequent videos in the series, you're not going to have them either. So we don't have the path to those cards, but we're still going to talk about them anyway. There were cards available to allow you to support the wireless hand control, the CD-ROM drive, the VIS audio, and the VIS video, the Sensation DAC, as well as the Save It card. So there was actually, you could install a Save It card in one of the expansion slots in your PC via this 16-bit expansion card. Now, those cards may not be available to us, but in the age of modern VIS development, we live in the age of cheap CD-ROM and CD storage devices, and as much as it's not environmentally friendly, we can make a bunch of coasters in pursuit of creating applications for the VIS, should you so choose at the end of this series. Either way, the VIS development hardware allowed someone to turn a PC into a VIS-like thing and help aid in development before they actually ran it on the VIS player. In addition, you could get copies of the Modular Windows SDK, which would include 2 different manuals, the programmer's reference and an introductory guide, which also included an SDK CD-ROM, which you could use to install Modular Windows on your PC, which is something we're actually going to do in a future video. We're going to install a copy of Modular Windows, and we're going to take a look at it. It's going to be fun, right? Right. Beyond that, that pretty much is enough to get you started, since this is a PC-like platform, and the Modular Windows documentation, along with Tandy-provided BIOS documentation, should be able to get you started. Since this isn't really a foreign platform, it's not a new processor, it's not a new operating system, you should have an easier time porting your application to the platform with the basic documentation. At least, I'm guessing that was the theory. So what's it actually like to be a developer and register a developer application with the VIS? So let's do just that. Let's register a new developer and title with the Tandy registration database. We'll use that to generate a license key, and then we're going to generate a license CONTROL.TAT file and create a custom disk for the VIS. Alright, so I have up here, I've got the 4833 in front of me, and up just above me, I've got a copy of the Tandy registration database, and we're going to take a closer look at that now. Here I'll just use my full screen command prompt. Let's just Alt-Enter that so we get the whole thing. Alright, so on this thing, in addition to the development tools, I have a VIS directory, and I have a Tandy directory, and this is the directory where all of my good stuff from my Tandy cache lives here. And you see there's a whole lot of good stuff. We'll get into some of this later. Teaser alert. So let's go into register here. That's where our good stuff lives. And if I do a quick directory, you can see I've got some C files here. I've got some source code for the utilities. We won't be looking at that tonight. I've got a register.exe, and I've got register.dat. Well, as the bit of screen above me is already kind of given away, register.dat is nothing more than a text file. And let's take a closer look at that, shall we? And here we can see, looking at the registration database, this is the database of files. This is actual register.dat from Tandy Corp. So you're looking at the file they use to generate the registration database, or at least one of them. And here, looking through this file, we can see a bunch of various titles here. So we've got the sampler disk. We've got the sampler disk file 1992. We've got a video tutorial disk from Tandy R&D. We've got some Microsoft folks, Multicom Publishing, Search for the Sea, the Better Homes and Gardens Cookbook. We saw that demo last time. Astrology Source 1, I'm pretty sure I've got that title. Last update, 16 December 92, which I don't know that that date's correct, and we'll see why I say that later. We can see here a bunch of information about some other titles. Here we're just going to look at some of the titles first because this is kind of fun. Rick Ribbit Adventures in Early Learning, that was the demo we watched last time. License A, you can see this is a Class A license. I talked about the license classes, and it was licensed on September 17th, 1992. Looking through this, I think we have, let me just do a search here, Quest, and this title that was licensed but never showed up. We've got King's Quest V, we've got Mixed Up Mother Goose, we've got Space Quest 4. Now, King's Quest V and Space Quest 4 did show up on the sampler disk, but never showed up for real, as far as I know. And Eco Quest, also from the sampler disk. Now, these were all licensed on the same day, so I'm guessing they were just entered at the same time. You can see that they put white space between the vendors here, but I think that was just for easy reading. I don't know that they're necessarily required, given that each vendor is listed multiple times and there's just no white space between other titles from the same vendor. So this is very much a human-readable management system, if there was one. We've got the Wild Animals title, which actually I did shoot last time, but the audio was so bad I skipped it. We've got the Vision Multimedia Bible, Time Magazine Compact Almanac. Let's go down to the bottom of this here. Well, not that much of the bottom. And we have, this is my point about the last update date, 9 March 1993, a Class A title called Fitness Partner. This title does exist. It was actually released. And to my knowledge, this is the last title licensed for the VIS, at least given what I have in my possession. We've got a pinball game from 1993 that I don't know ever showed up. And we've got the Video Movie Guide, which did show up, licensed in December of '92. So breaking this down, we'll take a look. Actually, we used the Video Movie Guide to look at this here. We've got the vendor, which is Advanced Multimedia Solutions, the vendor contact, and a vendor ID number. The vendor ID number should be the same, as you can see up here, with these various Mask Publishing titles, all 1310 for the vendor ID. So you've got a vendor ID for your vendor. Each one should be unique. Now, given that this is a human-created text file, I guess we're keeping track. Then we've got the product. Now, again, I mentioned VIS titles are licensed per product key, and the license agreement did not allow you to reuse a key on another title. You had to get a new key for a new title, and each title was given a number, title number 1. Then you've got your license, License A or License C. Now, what I didn't mention is there was a hidden Class D license that one version of the register utility would generate. I have no details on Class D other than a Usenet post from Frank Dirtifor, which states that Class D opened up the platform and basically made all the functionality available. But he didn't go into what that meant, and none of the documentation or none of the trove of stuff I have now in my possession goes into any detail about that. The only thing I have is the source code, which shows that Class D does exist, and that when it creates the TAT file, it resolves it to a Class A title, but with a different output checksum, so the player does know. Anyway, and then we've got the date that the title was released. So let's say I want to add myself as a licensee. Well, I'm just going to go ahead and go to the end of this. I'm going to take a copy of this Fitness Partner, and I'm going to shift insert that. And the vendor is going to be TJBChris Productions. And I am, in fact, TJBChris. Now, I'm going to give myself a new vendor number. I'm going to search for 500 here and just see search, find 500. Just me. Okay, good. So I have a unique vendor identification number. Now, what are we going to make for our title? Well, why don't we take a title that was a menu selection from the sampler disk? That should be easy. It's a known working title, and we'll just separate it out onto our own disk. Yes, I'm going to make a wasted CD-ROM, but who cares? Let's take the demo for Rick Ribbit and see if we can make it execute by itself outside of the sampler disk. And let's make it a Class A title, because I'm a classy guy. I'm Class A, baby. Right? Well, okay, maybe not, but we're still doing that. So we're going to call this Rick Ribbit Test. This is my first product. One and done, baby. This is going to be License A, and today's date is, in fact, for SEP, September, not SEO. This is 25. Now, this is just a text field. The date doesn't actually matter. So now I'm in the registration database, vendor 500, product ID 1, and I'm a License A title. Okay. Now, how do we go about turning that license into a usable key? Well, let's do register. And this is you can see right here from the copyright, this program is a Tandy trade secret, do not distribute. This product never landed in the hands of developers. In fact, you're seeing it here for the first time outside of Tandy. Register version 1.2, 27 July 92. The first item required is the vendor number, 500. If the vendor is registered, other titles previously use the same number for this title. If this is the first title from the vendor, specify an unused number or enter 0, which will assign a new number. Okay, well, we already have you 500. Now enter the product number. The next unused number should be used when possible. Well, I already have a product number in there. It's product number 1. And this is in fact an A-class title. And there is my registration key. Now I'm going to use my trusty cell phone here and take a picture of that, because I'm going to want that and I'm not going to remember it. And it's readable enough. It's not great, but it'll do the trick. And it is with that key that we can now make a control.tat file. So let's switch chairs from being in Tandy Center to someplace in God knows where, USA, where we're making our own title, and we've just been given the utilities to make a license file for the VIS, and we've been given a brandy new Class A license key. Now here we are, we've left Fort Worth and we're in any place USA. I'm Joe Developer, and I'm about to make a VIS application. Tandy has graciously provided me with not only my license key, but the make.tat utility and a very important job definition file called job.d, which you see up on your screen now. This job.d file serves as a template that I will use to create the job file that will tell make.tat how to create the license file that the VIS will then understand. So let's kind of take a look at that. Let's go to make.tat, and we have a job.d file. So let's just edit this job.d and we'll take a look and see what it looks like. Now this file is very well documented, as you can see, and this one is an earlier one from July 25th, 1992, but the file pretty much stands and works as is, so we're just going to use it. And it tells you about the VIS menuing system not being available without a full VIS license. That's a Class A title, as I mentioned. And you have to provide your registration code for the project, which we got from Register not too long ago. Then we get to title it. And these characters here in the monospace basically give you the lengths of the fields. So this file is very well documented in that it basically shows you, and basically it does show you, everything you need to know and gives you the limits. It's pretty implicit. You'd have to be, as developers go, well, I live in the modern age of, anyway, you'd have to be rather dense to not get this. So, y'all get it. Now we have program 1, and here you can see some other examples of program lines. We've got program 2, program 3, program 4, and essentially what you can do is, again, sequentially load and run executables, and then when VIS gets to the last one, it'll reboot and start the whole process again. Now, if you need a real backslash, such as in a path name, you need to use 2 backslashes because the program that creates this control.tat is written in C and you have to escape your backslashes. So you basically have to escape it within the text file here or they won't come out correctly. And you can see that here on program 4. Min-win, A, whack, whack, fourth. That's a modular Windows program, for those wondering. And then, of course, we've got a:2.exe with some random parameters, or mouse.com with some additional parameters. Scrolling down even further, we can see that button 3.0 is the CD player. And we can see from the text here that it says if the customer presses the 3 button on the controller, when the VIS logo appears on the screen, the system will run the built-in CD player application instead of the application. And of course, there are additional options here that are not documented in this particular file, but that are supported with make.tat, and that includes a lot of the menuing system items that I mentioned in the past. But we're not going to get into that. We're going to make ourselves a file here that will allow me to create control.tat. So let's do this. Let's first save a copy. And I have a separate make.tat directory here with the utility. And I'm going to call this ribbit.job. Okay. So the first thing we want to do is enter our license key. Now, those of you watching, you could just take this key, if you have a copy of make.tat, and you could use it. As you're going to see, there's no checks. It doesn't matter. The whole point here wasn't to stop some schmo like me from running code on this thing. The point was to have a point of enforcement for legal repercussions. So if a developer reused a key or a key got out or they were misusing their license, Tandy could send an army of lawyers and go, stop it. You owe us money now, right? Or stop doing that or whatever they would do. At this time, with CD mastering equipment and the era of cheap CDRs not being a thing, schmoes like me couldn't just make CD-ROMs on a CD-ROM player. It wouldn't work. There's nothing we could do. None of us had this available to us. So they weren't worried about me or, today you worry about modern-day hackers, random people out in the public hacking the Nintendo Switch, for example. They didn't have this problem because the equipment and the tools and the technology weren't there for everyday schmoes like me to have that available to me. They were worried about other developers and having an enforcement mechanism for consequences were you to violate the license. So if someone shared the license key, they would have the ability to find that. And there was a utility that could be used to verify a license. Okay, so back to the license key. And by the way, the sample license key in the job file will work as a Class C title. So when you don't get the VIS menu system, you can run MakeTap with the default key, and you'll get a bootable VIS disk. Fun fact. Okay. So mine, CF, capital F, K0. Okay. And I'm just going to read this aloud because why the hell not? You can see it on the screen without mentioning the case. FF less than KJ plus L question 0 brace WC paren C bang underbar percent brace K0. I think we're good there. Okay. I think I got it. It'll tell me if I'm wrong. We'll revisit. Okay. And I'm going to call this TJBChris tries Rick Ribbit. I'll leave that out. I don't know how exclamation points are going to go. And today is again for Sep 25. We'll save that again. Okay, now for the program. This is where we need to take a quick detour. We're going to have to create the application area on our disk here to set up the CD-ROM, and we're just going to basically create the directory as it's going to look on the future CD-ROM. So I've got my VIS sampler disk already in the drive. Let's exit the editor, and we're just going to go CD backslash. I just meant to go CD VIS. Make dir disk, CD disk. All right, here on my CD-ROM drive, let's take a look at what we have for directories. And we have, that's right, the directory was rickrib. So let's take a look in our rickrib directory. Okay, demo. So here's what I'm going to do. I'm going to copy the entire contents of the rickrib directory down to my drive C. And that's because I don't know how the demo was coded. I don't know if it cares about the paths. So I'm going to copy the entire demo down, and then we'll tell CONTROL.TAT to run the demo with the pathing intact. So let's do this. xcopy/e rib c:\\VIS disk rick rib. That's a directory. And this should copy everything down from drive D to drive C. Okay, go to drive C. And this looks good. Perfect. Okay, what do I have for exes in there? Demo exe and rickdemo.exe. I'm going to go with the hunch and take the one with the later file date. All right? We'll gamble, friends. Let's hope this works. Okay, so now we have our application on the disk. We need to make CONTROL.TAT. Now, CONTROL.TAT, as you saw on the sampler disk, has to go in the root. So let's go back to my ribbit.job file here. And we're gonna, there's my license key that we just typed in. There's my TJBChris tries ribbit, which by the way, you'll never see except if you type the file on a PC. All right, we're gonna use this one here. Now, we don't need all the spaces. It's out there in case you need it. So, interesting thing about the VIS. Drive A is the CD-ROM drive. Drive B is the Save It card, but there's a big asterisk on that, and that it's not a mountable file system. We'll talk about that in a subsequent video. But the VIS technically supports bootable cards with the development hardware and a very special utility that Tandy would provide. With 32K, you don't have a lot of space, but it did support this. So you could technically run from the Save It card. It required a TAT file as well. Subject for a future video. Anyway, we know that, actually, this is rickrib. I just forgot where I was going. Demo, and it's rickrib demo, rickdemo.exe. Okay. So we're going to rickrib demo, rickdemo.exe, right? Rickrib demo, rickdemo.exe. I think we're good. Let's type it out. Actually, let's do more. Oh, you can't do that. You can't. Linux habit. You can't type more space in the file name. It doesn't work. So if I go more, it's going to get mad at me. See, I have to type, but it's habit. It's habit. Anyway, so there's my license key. There's my text. A, whack, whack, rick, rib, whack, whack, demo, whack, whack, rick, demo. Don't care about button 3. So there we go. So now we have to make TAT on this file. It just built control.tat. That's it. And as you can see, make TAT generates the control.tat files for VIS system disks, copyright Tandy Corporation. Now, this version is for use on fully licensed products only, and it is version 1.13 from October 1992. As you can see, it already generated the file because I specified the file, the job file. So now I have a .tat file, 492 bytes. Let's copy that to our disk. And there's my files. All right. So with this, we should now have everything we need to take the Rick Ribbit demo with our newly minted control.tat as a Class A license, baby. And we should be able to boot it on the VIS. And here's what should happen. We should get the pop-up that says that it is an authorized VIS title when the disk starts to boot. And then the Rick Ribbit demo should start. And when the demo ends, the player should reboot, and it should go through the whole process again. So let's go over to my laptop, and we're going to make this disk. And here we are over at my HP laptop. This is one of my lab machines. I'm sorry for the terrible screen cap here, but you're just going to have to deal. Let's see if we can zoom in, give you a little better view, but sorry about that. Didn't have another capture device available. So I'm over here. My files are copied, so I've got control.tat. And if I look at the control.tat file, you can see I've got my A, rickrib, demo, rickdemo.exe, which is where I am here. And if I look in rickrib and demo, I should have rickdemo.exe. And there we are, rickdemo. So this should do the trip, assuming I didn't have any typos or anything. So let's go over and run our Easy Button CD program. I'll put a disk in my drive here, and we're going to do a data project. We're going to add some files, and we're going to go to, they're in documents, and VIS Rick. We're going to add both of these, and that should show all my files. It does. Okay. So we've got the data disk, and I'm going to call this VIS Rick Rib Demo. It's on the blank CDR. All right, now the VIS, being older, can be a little picky with burns. I'm going to turn the burn speed down, turn off burn proof. We're going to burn it directly without saving it to disk, and we only want to burn one copy. And let's just let this thing go. We'll burn it to disk. And here we go, we're writing out the track, finalizing the disk. Now let's see, once this is done, how it plays on the VIS. I'm just waiting for it to say success. Come on, Schwartz, finalize that mofo. Bazinga. All right, friends, we have our disk. Let's see what it looks like. All right, if this works, it should say it's authorized, and we should get Rick Ribbit. Okay, it's authorized. It worked.
Tadpole Productions presents Rick Ribbit, Adventures in Early Learning. Frog. 3 sons. Brew.
And there it goes, and it's going to reboot again because it ended the demo. Now it's going to reinitialize, reread the disk, same authorized title, and then it's going to run Rick Ribbit again.
Tadpole Production.
Well, friends, now that we've actually made a new title for the VIS, and by new I mean I made my own license file to run some old code, I want to look at something that we didn't look at last time, but is part of the VIS, and that's the Audio CD Player. And I can't think of a better way to do that than with a Herb Alpert CD. Now, we're not actually going to listen to any of this because, well, copyright. Herb owns his music, and he's understandably rather protective of it. But I'm going to put this in. We're going to show you what it looks like, and I'm just going to mute the audio when the music starts to play so I can show you kind of how it works. You might get like a second or two, but you're not going to get much. Okay, so here we go. We've got my Herb Alpert, and this is Classics Volume 20. A&M, for their 20th anniversary, released a bunch of Classics albums. The first one was Classics Volume 1, which is the 2 on a brass. I have another one that's Sergio Mendes in Brazil 66. Is that Volume 4 or 6? I don't remember now, but I do have it somewhere. Anyway, let's put this disc in and see what happens here. Use hand control to control the player. And if it does start playing, I'm going to stop it. And it's a modular Windows application. Yay! And there it is. Okay. Hasn't started playing. Oh, and it started playing. So we're just going to stop that. Okay, hopefully that didn't play too much. Now, the interesting thing is, because I have the Save It card in here, I can actually I can pick the tracks. This disc doesn't have too many tracks, but I can go all the way up to 14. I can play all, shuffle. Gives me the usual CD player controls. I can scan the tracks. I don't know how many seconds it scans. Interestingly, I can name the disc. So this is H. I wish I had a way to do this better, but it's not. E, R. I'm pushing the A button on the hand control, by the way, to select. And I just have to go caps. I'm just going to call this Herb Alpert because I'll be here all night typing. Let's see, P, E, R. You have no idea how many people call him Herb Albert with a B. He is not B, he is P. Anyway, enter. And let's see. I can change tracks. So, of course, the first one's Route 101. This here is going to be Rise. It'll play a little bit of that. But, of course, I'm not going to let much of that play because heck no. So maybe I want to pick another track. I can just keep going through. Let's go to track 9. Now, you can make a programmable shuffle here. That was this drive freaking out because it was seeking track 7. It's still seeking. I can tell it to unseek the tracks. Oh, it does it as you go. I see. But I can make my own little program here if I want. So actually, let's try this. Let's take out 6. I didn't necessarily care. Let's take out 8. All right, so if I play this and I got this right, it should play tracks 5, 7, 5, that's Fandango, track 7, even flashes it, and 9. So as you can see here, without getting a copyright strike, it plays. I can make a programmable thing just like a standard CD player. It's got a scan, so you can play all of it. You can shuffle. It's your standard modular Windows application, but it does in fact work, and it's honestly not bad. And I can pick my repeat mode, just go repeat, whatever. And of course, I've got my additional tracks. I can change the time to elapsed or remaining. And of course, the name for the disk is now stored on the Save It card. So if I put this disk in the future, it will read the disk ID and it will say that it's Herb Alpert. This machine cannot do CD text. It predates any of that. So if you throw a CD text disk in there, it's not, as far as I know. I've never seen it work with one. I've put a few in there and it hasn't. Now someone's going to go, I put a CD text in there and disk in it where it worked. Well, but I haven't had that work. I think CD text comes after this. Anyway, that's the CD player. It's actually fairly usable. I don't know that I want to leave the image up on my TV all day, but I guess you could turn the TV off and just go with it. So I think that's going to do it for our look at licensing on the VIS. You've seen a lot of unique stuff here tonight. You may not realize it. It may not be that interesting. The larger world may not GAF, so to speak, but you've seen proprietary Tandy documentation, you've seen a proprietary Tandy licensing utility and the actual registration database, and you've seen me make my own Control.TAT file using my own privately generated license key using Tandy's registration database and their utilities. We made the disk, the thing booted with my Control.TAT file. I don't think it gets any better than that. And that, my friends, is the gateway to running applications on this platform. Until we could actually make the Control.TAT file, we could not write new applications for this and have them run. Now, if you noticed, the Control.TAT process doesn't actually need the executable. So it may have been possible all along to take an existing disk that maybe had a DOS application on it, create the executable with the same name, and have it run. Will it work? I haven't tried. Maybe we should. But either way, it feels more legitimate to actually be able to generate the keys to this platform. And now you've seen it here first, you can generate the keys for the Memorex VIS platform. So I think that's a good place to stop for this evening. Join me next time when we're going to talk a little bit about the software environment for this. We're going to dive into a little bit more about the BIOS, and we're going to check out Modular Windows and the Modular Windows SDK on the PC. So until next time, thank you for joining me, and cheers to you and the VIS.